golden mean, the golden ratio, the golden segment. That's what we're talking about today. We're also going to talk about the Fibonacci sequence.
Fibonacci sequence!
And we are going to have a great time. The golden mean. There's a lot of historical background of this, and basically why I'm talking about it is because it is essential to understanding geometry, sacred geometry, and mathematics. And just because I'm really trying to apply mathematics to nature and mathematics to sort of the spiritual realm, this is important to me. Because I wouldn't care otherwise, to be perfectly honest with you. I don't give a shit in general about just numbers. I mean, to me, that's always just been like, why? Like, I don't care. Couldn't we have just used, I don't know, anything other than what we've chosen to? I mean, I've rationalized this out pretty thoroughly. So, in order to really do this project, I'm using my brain in different ways to understand math. And this is one of the essential elements of this study, is the golden ratio. And it's a big topic, but I'm going to cover it as thoroughly as I know how here. So, by giving you some demonstrations and some examples and some fun sounds and some, smiling, all that stuff. Alright, so get ready, because this is the golden mean explanation. And for this explanation, I'm going to use this shell, this very tiny shell, sorry I don't have a bigger one, to illustrate the principle of the golden mean. The principle of the golden mean, to me, is about growth. It's about ratios and growth. It's literally the mathematical equation for growth. Because the whole point is that the big thing, which, the shell's tiny, but the whole of the shell is equal to all of the little parts of the shell. Inside here, you can see all these little tiny parts of it. This is similar to the nautilus shell, which is often used to explain this process. But anyway, these little segments, if you took a little segment, the one you find in here is equal to all of the ones before it. Every time something does something like this, something grows, the ratio of each segment is the same mathematically. And that ratio is 1.618, which, I was like, whatever, when I first heard it, but it actually is pretty fascinating that we've been able to sort of calculate growth, and that natural growth is the same. Straight up, all across the board, it all has this ratio. What the fuck? That's kind of trippy, right? And a good metaphor for it that I read in this book by Bruce A. Rawls. It's called Sacred Geometry Design Sourcebook, Universal Patterns. Sorry, I shook the computer. The metaphor that person uses in their work is that each generation, if we use the human race as a metaphor, each generation is bringing with it the experience, their ancestors, basically, and the whole thing. So that's how we are moving up, is that there's sort of a propulsion involved but it's a spiral. And that, I could talk about that all day, how this is important spiritually. But I think just for today, the importance that can be extracted from this explanation is that there's commonality in nature. The commonality is actually mathematic, and so if you're a numbers person, it's proven. And that, so I don't know, I could really go on and on about this, but anyway, the ratio looks like this. If I were to write out the ratio mathematically, it's phi, which is, it's similar to pi in that it's a irrational and infinite number. So it's a decimal number that goes on forever. But it's not pi. It's PHI, named after the person that built the Parthenon. I'm not going to be able to pronounce the name right now, but that's them. And they, and basically it means 1.618 is PHI.
This is the Greek symbol for phi, and it equals 1.618.
So that's what phi is. But the ratio, the mathematical ratio that to understand like growth patterns like this is the whole thing, or phi, plus 1 divided by phi. That's it. Right? Yeah. Divided by phi equals phi over 1. So if you're a math person, your mind is blown by this. If you're like me, or maybe some other people that are watching it, I'm just like, whatever, that doesn't make sense to me. But hopefully the explanation that I said before, this one is helping. But it was used, literally it's found in a lot of the architecture that we pay money as Westerners to go visit and explore on our vacations. It's in the pyramids of Giza. It's in Egypt, all over the place. The Parthenon is supposed to be, it's supposed to have used this, but it's actually, there's a lot of conflicting reports on that. Some sacred geometricians, some sacred mathematicians, or whatever they call themselves, have said that the Parthenon is actually designed around the number 9 and not phi, so whatever. And actually, apparently it was used for the painting of Jesus. Who did that? Da Vinci's Last Supper. And so there was if you actually analyze the painting, there's a growth going on with the structures of it, and that would, anything that involves structures or growth will equate to this. So, I hope that was fun to learn about that. Okay, so I just wanted to talk about also some of the historical significance of the Golden Mean. And all the sources that I found basically spoke about the principle as being brought to Western culture 2,400 years ago. And I really do specify the Western culture part because that is the lens through which we understand this mathematical sequence. It was likely discovered by someone that was not a Westerner. And when a person that was a Western individual traveled to that place, they extracted this theorem. The reason why I speculate on that is because in my studies I found that a lot of these mathematicians were traveling and studying in Asian countries and Africa, and they brought the knowledge that they, acquired back to the West, and that's when it was written about, and that's when basically white folks heard about it, and that's how we're looking at it today, is from that perspective. I'm not specifically saying it was colonialization in there, but I would wager that it was.